Let's see. All right. Good morning and welcome. We are going to talk today about what happens if we have more than one rate of acceleration. Now, previously we have talked about, we have been using formulas from page 58 and from our formula chart, but I told you guys when we first learned those formulas that those are only good if you have one rate of acceleration. And I mentioned to you that if you have more than one rate of acceleration, that we would have to do something different. And today is a different day. We're going to learn what to do if you have more than one rate of acceleration. Spoiler alert, the short answer is you have to solve it in parts. Okay, but we're going to look at a sample and see exactly what that means. All right, so what if I have more than one rate of acceleration? All right, here's our example. A driver starts from rest and accelerates at 3.5 meters per second squared for 6 seconds. At that time, he moves his foot to the brakes and slows down at a rate of 1.8 meters per second squared for 4 seconds. How fast is he traveling at the end of the braking period, and how far does he travel during the entire trip? Okay, so what we see here, if we were going to write givens, okay, which will be our first step, if we were going to write givens, and I said, and what is the acceleration, what would you tell me? Yeah, you would say, well, it's 3.5 and 1.8. And so, and because he has, and in fact, it's, since this is slowing down, that actually will be negative 1.8. Um, so, whoops, didn't mean to do that. Okay, negative 1.8. So the question is, what do we do for that? Do we add them together and solve it as one thing? Do we average them? Do we, what do we do? How do we work that? And the key is we're going to have to work it in two parts. We are going to have to work the gas pedal part and the brake pedal part separately. Okay, and so we'll do that and we'll be good. So I want to work what I'm going to call the gas pedal part. If you want, you can call it the gas pedal or you can call it part one. Okay, but we're going to work the gas pedal part. And so what we need to do is we need to come up with givens for that. All right, so I'll start us. The driver starts from rest. Okay, so VI for the gas pedal part is 0 meters per second. Um, what's another piece of information that they give us for the gas pedal part? There's two more. Yeah, the acceleration. And so we accelerate at 3.5 meters per second squared. For how long? Yeah, for 6 seconds. And then it wants to, we're not to what we want to know yet, so I'll just kind of leave it at that. And then I'm going to switch to, let's switch to green for our second part. And I'm just going to, ooh, that was not at all straight. There we go. We'll divide that and we'll have the brake pedal part over here, or part two. All right, so then our brake pedal part is, now, what what do we know about the brake pedal part? What do we know? What do they tell us about that? So here's where we'll switch to green because it says at that time, meaning after 6 seconds, he moves his foot to the brakes. Okay. And then what happens? All right, he slows down and it gives us a rate. And we see that that's meters per second, so we know that that's an acceleration. That is a wonderful insight. I love what you're saying there. Everybody listen to that, and I'm gonna say it again. The initial velocity for the brake pedal part will be the final velocity of the gas pedal part, because whatever his velocity is there, he's going to then move his foot over to the brakes. And so the starting velocity here, hey, when you're driving and you move your foot from the gas to the brakes, the car doesn't just stop. However fast you were going, that's how fast it's still going. And so the final velocity from the gas pedal part is the initial velocity of the brake pedal part. Okay. And so that is very good insight. And the brake pedal is, there we have that. So the final velocity here, which we'll find in just a moment, will be the initial velocity here. Great job. What else do we know for the brake pedal? All right, the time is 4 seconds. And then it says how fast is he traveling at the end of the braking period. So we want VF, kind of VF2, if you will, or VF at the end of the brake pedal period. And then it says how far does he travel during the entire trip. How will I figure out how far he's gone? Delta D, the displacement. Now, can I just figure that out at the end, or for part 2? Do I need to do anything related to that in part 1? Well, it turns out that he's traveling and moving during part 1, so we'll have some displacement there. And then he travels and moves in part 2 that is not accounted for by this. Okay, and so we will in fact have to find delta D for part 1 and delta D for part 2, and then add them together in order to get his total displacement. Okay, do we feel okay about that? All right, I see some head nods. Okay, great. All right, so let's find VF right here. I'll write down a formula. My favorite, VF equals VI plus AT. All right, and so we will substitute our numbers there and get a value. And I'm just going to pause while we do that. All right, and so when we put our numbers in there, VI of 0, acceleration of 3.5, time of 6, we get a VF of 21 meters per second. Now that is not our answer yet, but we are going to use that in the second part of our problem. So there's 21 meters per second, which means this will start out at 21 meters per second. Let's go ahead and do the second part of this and go ahead and get VF. So let's do VF2, which will equal VI2, VF equals VI plus AT. In this case, we've got VF, which will equal 21 minus 1.8 times 4. Excellent. And so VF2 will have a value of, has anyone crunched the numbers for me yet? All right. All right, and so we have confirmed that VF2 is 13.8 meters per second, and that is in fact then our answer for how fast he's traveling at the end of the braking period. All right, now we need to do some solving for displacement. So delta D1 will equal VIT plus 1/2 AT squared. We'll put our numbers in there. Delta D1 equals 0, and that will zero out that whole term, so I'm just going to put 0 in there, plus 1/2 times, our acceleration is 3.5, and our time is 6 squared. All right, And so we'll get a value there. We'll get a value for that. And then we'll go ahead and do the same thing for delta D2. VIT plus 1/2 AT squared. VI this time is 21. Don't forget that it's not 0. Times 4 plus 1/2 times negative 1.8 times 4 squared. 4 squared, yes. And then we'll get a value for that, and then we will add those together. So pause the video for a moment and finish out the math, and then add them together and get a total. All right, and so for delta D1, when we did the math, we got 63 meters. Delta D2, 69.6 meters. And then when we add those together, we get a total value of 132.6. All right, so that is how we work a question if we have more than one rate of acceleration. You must work it in parts with each rate of acceleration treated separately. All right, I hope that was helpful, and you guys have a great day.